the three people that we have sat here have got the most amazing projects to show you. I don't think, these particular subjects have been touched on collectively ever before and will do ever again. They bring together Antarctic, lunar and equatorial projects, and they're really quite amazing. So our panelists are Hugh Broughton from Hugh Broughton Architects, Christina Silen from Studio Silen, and Thomas Rushek from AETC. I'm going to hand you straight over to Hugh, who's going to talk about Antarctica and the fun he's had over there. Hello, Hugh.
Hello. Well, thank you so much. This is a lovely opportunity just to very briefly introduce you to some of the challenges involved in designing for extremity. I'm starting first because I'm the chilliest of the three environments. Actually, I don't know if that's true. It may be much colder on the moon, perhaps. But I'm going to be talking about some experiences gathered designing for polar regions, and in particular in the Antarctic. And one of the fascinating aspects of designing in such extreme environments is that it really does pull together all the skills of the designer. So whether that's looking at the impacts of logistics, engineering, construction, but also the psychology of living in extreme environments, deprived of many of the sensory elements of our lives which we all take for granted. Also the challenges of keeping out extreme temperatures, whether that's hot or cold. Of course, the main reason for building in the polar regions is science research. The science drives everything. It's the reason why every one of the 40 or more countries who are based in the Antarctic is located there, to try and help to unlock the scientific issues which determine the global changes in our climate. The British have been operating in the Antarctic for 100 years, since Captain Scott first attempted to reach the South Pole, then reached there but didn't come back. And the British Antarctic Survey itself has been operating in the Antarctic for more than 50 years. This station I'm going to talk about is called Halley. We designed the 6th version of it. It's the most southerly research station that the British operate. It's around 900 miles from the South Pole, and it's located on a freezing, floating ice shelf, which means it's on ice, which has flowed off the main Antarctic continent and is literally bobbing about on the ocean. It's extremely cold at Halley. Temperatures go down to minus 55 degrees centigrade in the depths of winter. It never rises above freezing during the summer. You get snow accumulation year on year of 1.5 meters, which never melts, which means that everything you leave on the surface gets buried, and it's subjected to winds regularly in excess of 100 miles per hour. In terms of construction, it presents significant logistic challenges. Everything that is needed to build a new station and to help run it has to be delivered by ship onto fragile sea ice of only 2 or 3 meters thick, with a limited bearing capacity of only 9 tons, dragged across that sea ice and up onto the ice shelf before you can start building buildings. And that weight limit of the 9.5 tons means that you cannot possibly prefabricate any buildings. All you can do is bring in the bits to click together for your final project. The cold also means that you can only build for 10 weeks of the year, making it an extreme challenge with a number of key dates that you have to meet in order to complete your project. And this is our completed station, Halley 6. It was opened in February by the Science Minister, David Willetts, earlier this year. And it comprises 8 modules, 7 of which are blue, 1 of which is red. And they're split in 2, with the science modules on the left hand of the screen, that's towards the south, and the main habitat modules to the right. They're split in 2 so that if there is a catastrophic fire, for example, the residents can escape to one side until they can be rescued, which may take many, many months. The modules are arranged in a straight line because the wind only blows in one direction, and in this way we can predict where all the snowdrifts will occur, preventing the station from getting buried. There are 2 modules facing each other, which are used for energy production, so that if we have one set of generators fails, then the other set can kick into action. And at the heart of the station is a big red module, which is used for the main social space. Of course, the key activity at Halley is science research. They look into astrophysics, meteorology, and a broad spectrum of climate research related to changes in global environments. And on this upper level meteorology laboratory, this guy here is taking readings of the ozone layer, and it was in 1985 at Halley that 3 scientists first did discover the hole in the ozone layer, which is one of the most important scientific discoveries in terms of environmental research, probably of the last 40 or 50 years. At the heart of the station is this big red module. As you'll have noticed, all the modules are raised up on legs. The legs are hydraulic and supported on giant steel skis. The hydraulic legs allow the station to climb up above the rising snow level, and the skis are used both as spreader foundations and also as the means of relocation. So you can disconnect one module from another, drop them down on the hydraulic legs, pull them using bulldozers to a new safe location if there's ever the risk of the site breaking away from the continent as a giant iceberg. Inside the station, we carefully considered all the requirements of all the residents to introduce as much natural light as possible, to introduce colour, to introduce natural materials. And here you can see the stair which leads to the upper level of that red module, which is lined in Lebanese cedar veneer, which is the only veneer that gives off a natural scent, recognising again the sensorial deprivations that the residents have to go through. Heading down through the station, we were very conscious of all the modules being arranged in a straight line. So within each one, the corridor widens, it narrows, the ceiling height rises and falls to give changes in the atmosphere as you walk from one to another. We work very closely with a colour psychologist to develop a special palette of colours to help the residents overcome the effects of seasonal affective disorder, which they suffer significantly during the 3-month winter darkness. Within the bedrooms, we made them as comfortable as possible without excluding the role of communal activity, so not too big that people would just hide away there for long periods at a time. This allows the people to survive through really the most extreme winters that our planet can throw at you, and has also allowed us to generate experience, meaning that we can now call ourselves one of the leading designers of polar research stations. That's because we've done 2. We've done one for the British, now we're working top left for the Spanish, doing a laboratory for the Americans in Greenland, and have also looked at designs for Korea, India, and for a number of other projects. So that's my lot. Thank you very much.
Thank you very much, Hugh. That was absolutely amazing. It appears that it's such a separate science from what people are normally doing. It's no reason, no wonder you're now the leading Antarctic architects. I'd like to pass you over now to Christina Seilen, where things are going to get a little bit warmer. Christina has been working in Equatorial Africa, and she's going to tell you all about it.
Thank you. I'm Christina Seilen from Studio Seilen Architects. It is an honor to be talking alongside Hugh and Thomas, but I'm somewhat baffled why Africa is being put in the same category as Antarctica and space. I know that, I think it tells a lot about the reputation that Africa still carries today. As a place on the edge, as a wild, sort of Wild West place, and in many ways it is, but in many ways it is not. The pressures or the difficulties that we are dealing with are, I think, diametrically opposite to my 2 colleagues here. The first point is that we are dealing with hyperpopulation density, hyperpopulation increase. We are dealing with political strife. We're dealing with people who have to live together in very tight conditions, and that means that in terms of political organizations, very young countries relatively since colonization. So we're talking about countries that deal with hyperinflation, corruption, and lack of infrastructure in many ways. But we're also dealing with a land of opportunity. We're dealing with countries that have enormous population with an enormous amount of brain capacity, and we are dealing with countries that essentially are really at the beginning of their development in many ways. If I give you some hard figures about Africa, the population, for example, of sub-Saharan Africa was 800 million in 2007. And currently, the UN predicts that by 2015 we're going to have 1.5 billion. So an enormous population growth. More than 40% of the population in these countries is younger than 15 years old. So a very, very young population. As well, Africa currently generates 47 gigawatts of electricity, which is 0.6% of global market share. So very much affected by power shortages and lack of infrastructure. The foreign direct investment has been growing at an average of 146% annually, which is an enormous growth if you compare to any kind of developed or even undeveloped country. Lagos, which is one of the cities that we have most projects in, is the fastest growing city in Africa and the 7th fastest growing city in the world. The Lagos population in the 50s was 325,000 people, which is the equivalent of London Borough. Today it's about 10 million. And with the population growth estimated at 15 million. So the pace of change is roughly 40 people move or are born in Lagos every hour compared to 1.4 in London. So whatever we can bring to the place, or whatever the politicians can do to a place like that, it's very little. It's infinitely little, and we do have to think outside of the box in terms of how to tackle some of the issues. I'd like to show you two very different projects, both in terms of scale and in terms of site and in terms of what they're trying to address. One of them is in East Africa, and it was the first project that I used to start up my practice. It took us 9 months to design, and it's taken us 7 years to build. That's because we were dealing in a country with hyperinflation, a change of currency in the middle, political strife. Every time an election happened, everything would stop. Dealing with the fact that then there is not always food on the shelves in supermarkets, so the construction team had to deal with that. The fact that nobody has access to credit, so the client had to deal with importing all materials. So one of the things which I think is pretty predominant in the projects that we deal with in Africa is that the sites are absolutely fantastic. And in a sense, it is how do we simplify the whole process, and how do we come up with something that sort of breaks the boundary between essentially what a building is, which is organization of living, and the nature itself, and how do we protect ourselves just enough from the environment but also allow us to live with the environment. And this project was sited on a 50-meter cliff with a dam at the bottom of it, and behind it another 50-meter cliff, and building on rock meant that we essentially had to touch the site very lightly. Every time we put a bathroom, you had to get a stick of dynamite in to excavate. And also, we were dealing in a country which essentially was politically and economically very broken. So in terms of the procurement of materials and the achievement of quality, we had all sorts of challenges that came along our way. So in terms of the plan, it's a very, very simple plan. We have 2 living rooms. Well, let me get the... Hello. So we have two living rooms, a winter living room on this side and a summer living room which is open. And essentially it's a platform that sits on the rock and sits lightly and has been organized in such a way that we minimize the amount of excavation. And then in the lower ground of this structure, the master bedroom suite, and then further bedrooms and the support spaces, kitchen, office, etc. for the living spaces. The major element is really how do you deal with the sun. The vertical sun of Africa is very, very strong. It's absolutely vertical. Therefore, by using these very large cantilevered roofs, you're able to create 100% shading on all the spaces, and therefore you're essentially reducing the amount of performance the building has to do in terms of shielding itself. So what we were trying to achieve essentially is to live between the rock and the view, and everything on the design of the building is how do we bring nature in, how do we protect ourselves from nature, both in terms of animal, plants and sun, but how do we also work closely. Thanks. One of the major elements that we dealt with is that we had to be very flexible in our design. Materials are not available, labor is available but not skilled, and so everything that we designed was essentially, due to hyperinflation, purchased before or found on site. So for example, to clad the buildings, you can see initially we excavated the rock, some of the rock on site. You can see the dynamite lines, and whatever granite sort of peels off like an onion, and whatever was left off, which is called the crust, we then reused to clad the building, and that sort of gave its very rough sense, which works with the granite, but also allowed the building to really melt into its landscape. And similarly, essentially a lot of the design had to be done on site. And how do we? It's no longer becomes a CAD exercise. How do you come up with some of the design notions just by literally drawing on the site rather than drawing in a computer and sort of creating a stair in between large rocks? Interestingly enough, at the same time as we were doing the project in Zimbabwe, we were doing a project in Switzerland, and you couldn't have sort of culturally more diametrically opposed places. You can see on the top right, the Swiss had perfect formwork. They had the perfect equipment. You can see sort of 5 Swiss construction workers, endless discussions on the detail and the quality of the detail. On the left you have Zimbabwe at the same time, which whatever formwork we could find, health and safety you can see is maybe a little bit more lax over there, but the lack of availability both of construction materials and materials meant that we had to sort of really work much more closely in this environment with mock-ups and with trial and failure in order to achieve the quality. And I used to tease the Swiss that I think Zimbabwe probably achieved slightly better quality than they managed to do, and that sort of drove them absolutely insane. The other element that we tried to work with is that we were very humbled by the landscape and the beauty of the landscape and the way that actually the landscape changes over time. I mean, this will look like a deserted African landscape during the dry seasons and the luscious kind of green environment during the winter seasons or their summer seasons. But also, in the same way, we used the landscape as a building material. So for example, you can see here on the top left-hand corner, the pool is essentially, we put a retaining wall along the granite rock, and that became the pool, and essentially you can walk down through the rock into the pool, and it's part of the element. And really, this notion of connecting, you can see down on the right, this is the client outside of her bedroom, and we just created this very small reflecting pool so that there is this direct connection between the dam, which is 15 meters below, and the house itself, and this sort of continuity of landscape. This was the recording studio. The client was a musician, an artist, and so the recording studio was set inside the rock. And again, this notion that we went on site, we selected a site, and I literally on site with the workers did a hand sketch and decided how we would essentially hang a granite box in the middle of these enormous rock boulders, and how that would get built in a very remote site. And really, how does one connect with nature? And again, I think that the remembrance that it cannot be a paper exercise, and this notion that you've got to be there and literally sort of react to what you're given and create something unique in that way. Another project which is completely different and which we're working on right now in terms of scale is very different, but also in terms of the problem is that if you look at the numbers that I gave you, for example, for Lagos and for Africa or Nigeria in general, the population growth and the pace of change that is occurring means that there's very little data that you can react to. So we were asked to do a master plan. And what is a master plan? I mean, is it a pile of documents? Is it an organization of infrastructure and road networks? Is it sort of, taking a client's brief of X amount of square meters of offices and shopping malls and residential and sort of trying to organize them? Or is it something more that actually can adapt itself to the environment that it exists in? So our view was that they had done financial feasibilities. We felt that they actually were based on no real data. There is no real housing market. There is no real office market in Abuja. This is in the capital of Nigeria. It's a very young city that was built in the 60s. So essentially what we tried to do is to create a placemaking. And we started with a public space as opposed to with the buildings. And we said it's a very long site. It's a 3.5 kilometer long site along a lake. And we decided to create a very vibrant public space along the lake so that whatever real estate occurs behind it has a continuous access to a public space. So the first element was really creating what we call the waterfront promenade that changed its identity according to the uses behind it. So where residential elements were behind it, it became a residential park, and where a shopping mall was behind it, it became the retail park. And then the other element that we had to deal with is that the client gave us a very vague idea of what kind of brief to put in. And we said that instead of saying that you put the offices on the north site and you put the residential on the south site and you kind of do a Corbusier plan of functional city quarters, we said that, well, let's look at an African village. And an African village is really based on fractal geometry, where it is essentially a repetition of a form to create something bigger. But what does this allow? And if you look on the precedent of the African village, is that essentially a module repeats itself and changes itself, but then allows for different functions to occur in a very organic manner. And the important thing is that it's allowed to grow at the pace that it needs to. So if we were to sort of say, you put 5 skyscrapers on the side, the client is going to deal with, can the market take that and can it grow that way? So instead of that, we came up with a notion of a module of 15 by 15 meters and saying this can either be residential or offices or retail, and depending on how you put it together, it's kind of like a Lego-like module. It allows you to create different kinds of densities, but also different kinds of uses. And essentially, you then organize that on the site, but in a very organic manner. And the idea was to say to the developer, you have these different sites that you will give over to developers, but we are not fixing what you put on the site, nor how big it is. We are telling you how big you can go, depending on the parking requirements and the limitations of the site, but essentially whether if a developer wants to put 60% residential and 40% offices on his site, he will be able to do that. And if the market is 100% residential, again, they will be able to do that. But on the other hand, we wanted to create a community that was recognizable and made sense. So how do you keep complete flexibility while also creating something that has a structure and makes sense? So the organization of these 15 by 15 meter blocks on sites, and with a sort of a very few rules of how you organize them along each other and along the water edge, created something that allowed huge diversity but also recognizable identity. Some of the large oil corporations or international corporations will come to Abuja and will need both offices and residential spaces for their workers. And again, that was creating a community where essentially the buildings would grow as they need to and when they need to, and just by a few set of rules allow this complete flexibility of a development. Anyway, 2 ideas.
Thanks, Christina. Absolutely fascinating. Now, Thomas is going to take us out of this world.
Good afternoon, ladies and gentlemen. It would be great to zoom out a little bit and imagine where you are sitting right now. Here is London, here is also Africa, and here is Antarctic. And you can see that we are pretty much still on the beginning of our journey through Milky Way, our galaxy. For me, expanding the biosphere and protecting it on our planet is one of my passions, hobbies, and to be able to focus on such research, we started our company AETC, based in Prague, London, and Tokyo, to be able to pay the bills and at the same time to think about future projects like colony on Mars and so on. We are integrating in our projects various disciplines ranging from graphic design, augmented reality, architecture, or even space architecture and product design. And in my case, since we are an internet-based team, it was possible to go to Strasbourg to study a second master's of space architecture, and then to move to Los Angeles, where I was helping at NASA JPL to 2 teams, one in LA and another one in Silicon Valley. And if you have a look on our planet from this perspective, all of you that are now steadily sitting are actually moving almost 800,000 kilometers per hour, even if you don't feel the wind in your hair. It's good to imagine that we are not static. We are actually very fast-moving spaceship in the middle of nowhere. And at this moment in time, I think the biggest challenges involve finding some symbiosis between our built environment that we are creating from concrete and other material, and combining it with digital layers, and combining this together with green nature and original nature together in order to create something like Nature 2.0. That we would be able to export from here to other places in the universe. Now we are in a very exciting time when you can see each week new private space companies launching new modules to International Space Station and experimenting with inflatable space hotels. One friend is, for example, building his own spaceship, his own rocket in a garage in Denmark, and they are with very little fundraising building space hardware, and you can see this movement happening quite progressively now. In our case. We are doing research together, for example, with NASA, and also we were, for example, working on some projects like Omicron Space Hotel, which was offered to a British company, Excalibur Almaz, which has bought this former Russian module that is also part of the International Space Station, and they need to reconstruct it into Space Hotel. Other projects that I was working on involved, for example, my main goal was actually now to help with colonizing Moon and Mars. And if you think about going to Mars, it's a quite challenging thing that is comparable with Columbus journey to discover a new world. And if you want to go to Mars healthy come back, it's good, for example, to focus on things like artificial gravity that enables you to walk inside, to prevent bone loss, to prevent muscle atrophy, and it enables you, when you arrive to Mars, that you can normally walk there, and you are not you are not a handicapped person that need assistance, like what is happening now when the International Space Station astronauts are coming back to Earth. If you come to Mars, you need to be able to perform many tasks, to deploy the habitats. You need to survive quite extreme conditions. And in our case, I have created a team of 10 people in NASA JPL. We cooperated with like 2 leading scientists on artificial gravity, and also, for example, with Buzz Aldrin, that was one of 2 men first on the moon. And we created a series of concepts showing how we can use current hardware possibilities and how we can explore the artificial gravity effects on our Earth orbit, and also how to use it for a journey to Mars. And this is, for example, solar-powered Mars transfer vehicle with ion drive that you maybe heard about from Star Trek, but we already have this technology available. And this would enable you to make a link between Mars and Earth, that it could work like a ferry, shipping the people then and back, and it would stay in orbit between 2 planets. So you don't need so much energy to actually sustain the colony there. The most visible project from like our artificial gravity design session was a concept of a mission to asteroid. That was after like 2 months of our research, presented in Washington on a NASA conference, and it was showing it like one of the possible scenarios how we can get to asteroid when Obama was stopping the Mars program, and we were thinking what to do next. And in terms of Mars exploration, this picture is blending between Antarctic and Mars. If you want to go to Mars, it's really good first to train on our planet, and also then on Moon. And on our planet, the closest environment to Mars is actually Dry Valleys in Antarctic, and it would be possible, for example, to build there a simulation of Mars habitat that is now in the configuration for 10 people with solar arrays that can follow the sun and cover it during the sandstorm. And you can also use augmented reality to overlay the view of the astronauts, and also to use it for interaction with robots and other elements in the simulation. This was developed in the beginning by my colleague at NASA Ames, and then we proposed this analog simulation in Antarctic. And this project is actually close to one of the biggest temperature extremes, as we were discussing the very low temperatures in Antarctic. These places on the lunar south pole, where you have the craters where the sun never goes, you can find there temperatures almost 250 degrees Celsius below zero. So it's one of the coldest places in a solar system, actually. And next to these craters on the lunar south pole, we proposed new module for NASA that is created by 3D printing technology that is developed at NASA JPL, and you can actually build for even almost like 4 times bigger module thanks to using local resources, and you can achieve much better radiation protection and temperature extreme protection than with conventional modules. This module would be so big that you can think about building their artificial garden, and you can start using plants for recycling the water, the oxygen, and also for better well-being there. And such module would be really like creating first small biosphere in vicinity of Earth. The internal layout of the building is comprising of 5 inflatable membrane modules that are interconnected, and everything is covered with 3D printed shell that is actually built just by microwave sintering. And if you heat up the lunar soil just by microwaves, it can create a solid building material by sticking together, and you don't need to import other building material from Earth, which can save you so much energy and also cost. And this microwave would be held by the robot, which was developed to manipulate with the other modules. If you go to California, you can see these prototypes that are actually half the scale. So imagine that twice as big robot would hold on these like attaching hooks, big microwave fed by the lunar soil, and it would start printing layer by layer houses and shelters and also like hard surfaces. And recently, NASA started using our design in their proposals for funding to further develop this technology. The problem with all these projects is that if we try to be realistic and it will be used in, like, let's say 15, 20 years in the future, such designs will be already obsolete at the time of the use. So if you hear each week about like, new nanotechnologies and new inventions, we can see that these first lunar bases can be actually totally different, and it can be maybe built from shape-shifting nanobots that are now also being developed at NASA. Nanotechnologies can also help us to create, for example, space elevator that would help us to get from this gravity well that we are now, and thanks to that we can in the future unlock all the resources that are in space, where it is virtually unlimited, and it only depends on our motivation and technology. Thank you.
Thanks, Thomas, and Hugh and Christina. Thanks so much for these amazing presentations of what's possible now and what could be possible in the near future. I'd like to ask now if anyone has questions for Hugh concerning Antarctica, Christina in Equatorial Africa, or Thomas in space. Anyone have questions?
Hi, I would like to ask you, what was the cost of your first project, Christina, in Africa on these rocks? It was so beautiful, and what was the cost in pounds, more or less? Thank you.
The answer is I don't know, and I don't think anybody knows, because as I said, we were dealing with hyperinflation, so For example, we bought the concrete before we knew how much concrete was needed. A lot of the material was sourced on site, so essentially at the end of the day, and there was a change of the local currency to dollarization in the middle of the project. So I think the client has a vague idea, but a lot of the resources was used from his own organization. So the answer is we were not involved with that, and we wouldn't have been able to deal with that because we were not familiar with the way of trading. We employed a local architect when we were building it to be on day-to-day on site, and I asked him at one point, why is everything taking so long? Because it took us 7 years to build, and he said, at some point, the economy was not functioning properly, and so they all had to deal with the exchange of goods rather than the buying of goods. So you could no longer use currency in order to buy something. So you'd go to the window guy and you'd say, okay, well, I'm going to buy the window, but I'll give you thousands of liters of petrol. So it's not, and traditionally, I can't give you a straight answer because none of it would be really real. It's sort of, you just go ahead and you build it.
Thank you.
Next question at the back there.
Yeah, it's a question for Thomas. The 3D printing technology, I mean, I'm an architect and we use that kind of technology in our practice. And the way it works is on a bed that moves down, and that's how you build up your layers. So I'm just interested to know how it works on a static plane on a planet. How does it build up the layers?
Well, actually, you can use penetration of the microwaves up to 30-40 centimeters. So it means that you can build layers that are, for example, 10-20 centimeters thick, and you will have one bulldozer that is coming with the material to a feeding device, and then it will go with through the pipe that is taken from like current like industrial pipes, like conveyor pipes, into this microwave, and then it would be like deposited and heated up, always in let's say around 1 minute, depending on the power output that we will use. Yeah. So it will go very slowly, but you will save so much material that otherwise you would have to take from Earth.
Okay. And I do have one other question actually for sorry, I forgot your name, the gentleman doing the architecture in Antarctica. The kind of the buildings which you design, do you not also consider things like the wind as well? I mean, I know you mentioned things get frozen up, so I'm not suggesting that turbines are a good idea, but I mean, are you considering maybe utilizing wind power to then generate energy for those kind of buildings?
Absolutely. The problem in the Antarctic is that the wind is extremely violent. So you can get gusts of kind of 120, 150 miles an hour, and then you can get days of no wind whatsoever. And the problem therefore occurs that if you have a wind turbine, the gusts can be so violent that they can rip the turbines off their masts. Yeah. So having said that, there is increasingly advanced technology allowing for those gusts. The Australians have a station at Casey in Antarctica, where they anticipate that they will get 75% of their energy from the wind within the next 4 to 5 years. So I think over time, the use of wind energy and solar energy in the Antarctic will only ever increase.
Yep. Okay. Thank you.
We're nearly out of time, but I think we've got time for one more question if anybody's got anything. No? Well, finally then, just to say thank you to our panellists, Hugh, Christina and Thomas. Thank you very much.